Okay, so topic 2, that's going to be all over the test, is confidence intervals. Um, we have 3 different confidence intervals we learned how to calculate. We have the proportions confidence interval, the one for a mean, and the one for means. We have 2 different options. One, if we have sigma, we can actually use a z, and if we don't have sigma, we're supposed to use t and guesstimate sigma using s. A confidence interval gives us a range of possible values for the true population, either proportion or mean. So we're going to use a sample value, say that's a pretty good guess, and then we're going to add or subtract a margin of error to get what that guess is. So all of these confidence interval formulas involve 2 pieces, or the formulas. We have our point estimate, the value at the middle of our confidence interval, and that is just if I'm trying to guess at the real mean, I'm going to use the sample mean. If I'm trying to guess at the real proportion, I'm going to use the sample proportion. And then the second half of the piece, we add or subtract. This is our margin of error. So I can guess that the average height of an adult female is 5'4" plus or minus 2 inches, right? Or plus or minus an inch. That's the idea of here's our estimate and then how much variability or error is there really around that estimate. So these can be done, all these formulas can be done in the calculator using the shortcuts you can see here in the table. And all these things are on your formula sheet. If on the test you start hearing something that's asking about confidence intervals, you know you're in this section and you're just saying, is it for a proportion or is it for a mean? If it's for a mean, do I have or not have sigma? And that tells you which place you want to go. If you have sigma, you can use the z interval. If you have a sample standard deviation, you should be using a t interval instead. So let's look at some of these questions we had before. We do have a lot of stuff that I can ask you about confidence intervals. They're one of the big 2 on this test, confidence intervals being the first, hypothesis testing being the second. So you can see here, not only do we need to be able to calculate the interval, but we also need to be able to interpret it. We need to find a critical value, so you need to be able to figure out how to find this t star or the z star. And then I would also like to know, how do changing certain things influence our confidence interval? If we have a larger sample size, that means our estimated value for the true mean or true proportion using our sample is better, so our confidence interval gets smaller. If we want to be more confident we caught the real value, we need a larger confidence interval. So these types of ideas. And then knowing what assumptions are necessary in order to use these. In all these cases, in terms of the assumptions, just to quickly run through them, simple random sample, independence between our different values, our n has to be less than or equal to 10% of the population, and then you need to have your rule of thumb met. So rule of thumb, that's like large enough. For proportions, that's NP and NQ greater than or equal to 10. We don't have P and Q, so we use hats. For means, your n has to be over 30 to use a z interval if it's not originally normal. Has to be over 40 to use a t interval. Okay, I'm back. All right, so that's the assumptions that are necessary. And then the last thing here, finding a point estimate and a margin of error for a given confidence interval. Remember, your point estimate you can find by taking and averaging the 2 parts of your confidence interval, because that point estimate, this piece, is always the middle of your interval. You can find its middle by just averaging the 2 parts. Your margin of error is always this, upper minus lower over 2. It's this piece, because when you make your confidence interval, remember, say it's for a proportion, you take p hat and you add a margin of error. You take p hat and you subtract a margin of error. So you end up with not 1, but 2 margins of error wide. So if you do your range, you need to divide it by 2. That is a formula or a set of formulas that you probably want to put somewhere on your note card, right? So note card worthy is interpretation, finding this point estimate, maybe even your assumptions necessary. And if you want to, just quickly putting down those rules for how to make our confidence interval narrower, that might be worth putting on your note card as well if they're not something you just sort of know or can figure out from the formulas. We'll see those on the next page, I think. So first question we have here off of an old test. A survey is conducted to determine the average loss of home value in a certain community. Right off the bat, my eye is drawn to that average because we know everything in this particular test is either proportions or means. Average says we're in the means area. A random sample of 23 homes found a mean of 13,120. So this is a part I've had a lot of students in my office having trouble with. As soon as you see the word mean, you need to look and say, is this a mean for a population or is it a mean for the sample? In the same sentence as the word mean, we have the word sample. So this is the sample mean. We are going to denote this thing with an X bar. So X bar is equal to this 13,120. Same sentence. We have the word standard deviation. So it's still in the same sentence as that word sample, meaning that this standard deviation is an S. So it says, assume the necessary assumptions are met, all that crap I was talking about up there. And then it says, let's go ahead and calculate a 99% confidence interval for our mean. So if we were people without the sweet calculator, or even with the calculator, you might use the table here to sort of let you see what it, or the formula sheet to let you see what you need to do. We want to calculate a confidence interval for a mean, and we don't have sigma, we have S. This is the formula we want to use. We want to make an interval with a T. This is the heads up for those of you using the calculator, right? So when you come here and you go, okay, awesome. For those of us with a calculator, this is a T interval. So you guys can go ahead, just start typing into your calculator while I do this by hand, or fast forward till I'm done doing it by hand and check. To do this by hand, X bar plus or minus T star, S divided by the square root of N is what we're multiplying T star by. So 13,120 plus or minus. The T star, remember, is the one part that's kind of annoying here. In order to find a T star, doing this by hand, I need a degree of freedom, which is just n minus 1. So 23 minus 1 will be 22. And then I'm going to go to that T table I'm going to give you guys on the test, right? So if we're going 22 as our degree of freedom, you guys can't see it on my stupid ass screen because I'm not far enough over. There we go, 22. We need 22, and I don't remember, I didn't write down what the confidence level was. Did not read it at all. Confidence level is 99%. So using these two pieces, we can find our T star. 99% DF of 22. So DF of 22, 90, it's going to get worse if I zoom out. Okay. 99%. You guys cannot see exactly where it is, but we can do this anyways. There's our T star, 2.819. So now that I have that value, I can come back here, 2.819, that was my T star. I can finish plugging into this equation. S is 1600 divided by the square root of 23. If you're doing this by hand, my sincere recommendation is that you do this margin of error calculation first. According to my calculator, this is 940.48. And if we add or subtract that to get our interval, first thing we should do is the subtraction. We get 12,000. I can go ahead and put a dollar sign on this. 12,179.52 to 14,060.48. So there is our interval. You should have gotten something out similar if you used T interval in the calculator. You probably would have rounded a little bit more in T interval just because of the lack of space to put all of those decimals in there. And that would have been okay with me. Interpreting the interval, that's just the sentence we learned before. We can be, or we are, doesn't matter which, 99% confident that and here's where you get to cheat a little bit. And I had to have told you what the heck we're talking about. The population mean loss and home value. The population mean loss. So we're saying the population mean, our mu, and then what it is, loss in home value, is between, make sure we have our units, so the dollars is there, we're good, and 14,060.48 cents. All right, so get 99% confident that the true population mean loss and home value is somewhere between those two numbers. That's it. Okay, so here's another example. Reading through this one, we have a random sample. There's our N. We have 27 reporting having their taxes audited. That's our number of successes in X. And we're asked to find a 90% confidence interval for a proportion. So again, we can go to that formula sheet and be like, okay, boom, formula sheet. This time we're still in the confidence interval section, but we're talking about not a mean, but instead a proportion. So this is the formula we want, or one prop z interval in our calculators. So if you're doing this by hand, you'd be coming in here and saying, okay, I want to do p hat plus or minus z star square root p hat q hat divided by n, or we're doing one prop z interval. Only things to note for either of these groups, one prop z interval is really nothing you can mess up here. If you're doing this by hand, remember you have to calculate p hat as x over n. That might be note card worthy. And then your q hat is just 1 minus that, right? So you can do all your work there. I will just quickly do this in my calculator so that way I can tell you what the right answer is. But I do not want to do this whole thing out because we already did one by hand and that was the harder of the two. 90% confidence. The answer is C. All right. 4 is about the previous question. It says, if we calculated a 99% confidence interval instead of a 90%, so we're going to increase our confidence level. Well, if you increase your confidence level, that's going to drive up your Z star, right? You can even see it on the table. So if we're going to do that, what's going to happen, if we need to be more confident, you need a bigger interval. Nothing should change in terms of your midpoint, right? The only part it influences is here, which is all about how spread out it is, not the center. So the midpoint should stay the same. Midpoint is unchanged. The only way we change the midpoint is if we change our p hat. And the width should go up. So that's the only answer that says that. You might want to put something on your note card of all the ways that we can decrease the width, and then increasing the width moves in the opposite direction. Okay, got to get these things in there. Oh, in fact, let's just skip to 7 really quick. 7 says, which of the following will result in a narrower confidence interval for a mean? Well, the opposite, right? If we increase the width of our interval when we use a bigger confidence level, we'd want to decrease the confidence level. We'll be less confident about actually catching the real value, but trade-off, we have a narrower interval of possible values, which can be useful. Increasing the sample size also helps, right? That brings in our spread of our distribution. You can also see in the margin of error calculation for these formulas, whether we're using a z or a t, both of them have that square root of n as a denominator, right? So increasing your sample size will make that margin of error go down. And lastly, z's, if you look at your table, the z's are always smaller than all the t's. So if we multiply by a z, it is better than multiplying by a t. Now that doesn't mean we have the choice. We can only use z if we have a sigma as opposed to having an s. I'm running out of time, so I'll do the last questions, the 5 and 6, in a separate video that'll be shorter.